So our next example is we have to find the electric field produced by a ring of charge. So we just have to let the ring as like very thin. Okay, so para makuha na to iyahang pagka ang dimension. Okay, so para we can actually represent the ring nga mura siya og line nga gituyok. Okay, maghimo siya og circle. Okay, so a ring of radius A has a total charge of positive Q. Okay, na total charge na pod. Find the electric field at point P located on the x-axis at the distance L from the center of the ring. So, from the center of the ring, so ito. So here, we can just let our origin to be at the center of the ring mismo. And then the distance L, ito yung field point natin. Okay? So again, we just have to express our electric field using in terms of unit vectors. So we have EXI hat tapos EYJ hat. Okay? So here, first step is you have to get a small amount of charge. So suppose nandito siya. And then since positive yung total charge niya, so that is pointing away from DQ. So ito yung specific na contribution ng DQ ng arbitrary DQ. Ito yung chosen DQ natin. So we have here a ring. So a ring is actually like a line lang pero nga gituyok lang siya, okay? So dili siya kanang naay wala siya thickness, okay? So ito yung origin natin. Tapos ito yung like a y-axis, okay? So ito yung y-axis natin. Tapos ito yung x natin. So yung point P mo is a distance L from the center of the ring. So we can let the center of the ring as our origin, just like what I said. So the radius of your ring is, may radius siya na A. Okay? So suppose yung chosen na DQ natin is ito. So that is your DQ. Okay? So since positive yung total charge Q mo, so we just have to then that is pointing away exactly from the charge DQ. So ito yung field point P mo. Again. So the distance between DQ and your P is, say, R. Okay? So the electric field produced by this ring of charge at point P can be expressed in terms of unit vectors. Okay, so EYJ hat. Tapos yung EX mo is actually equal to the integral of K dq over R squared. Pero yung trigonometric functions niya ay function niya associate sa EX is actually sine theta. Why? Because yung DE mo is oriented at this angle theta. Okay? So ito yung orientation niya. So since according to geometry, if nagfo-form siya na ganito, parang X, okay? So just like what I said, yung theta here is actually equal to theta here. So the angle here is actually correct. So now, if titignan natin that your EX is actually the same orientation natin. So actually, it's not actually the sine theta, but this is actually cosine theta. Okay, so wrong na naman ako. So this is cosine theta kasi the theta here is adjacent. I mean the x-axis is adjacent to your angle theta. So tama lang na cosine theta ito. Pero I actually put it naman cosine theta on the EX. Okay? So since we let our ring of radius is like a line nga parang gi-form na to siya circle, so meaning we can let dq to be equal to lambda dl. Okay? So we have here EX, then k lambda, we can take k lambda outside because that is constant. So dl over r squared cosine of theta. Now the cosine of theta here is actually equal to adjacent over hypotenuse. So your adjacent is L over the hypotenuse, which is equal to ano? So since the distance from the origin to here is actually A, because for a perfect circle, yung all radius anywhere on a circle is actually equal. So we can take this one as A. So that is equal to the square root of A squared plus L squared. Okay, so meaning yung cosine theta is L over the square root of A squared plus L squared. So I would just put it here, cosine theta L over the square root of A squared plus L squared. So we have here K lambda, the integral of DL. So, wapatay DL. But your R squared is actually equal to A squared plus L squared. Then we have here L, then square root of A squared plus L squared. Then simplifying, yung L mo actually is not a changing variable kasi it is constant all throughout. Even though nandito yung DQ mo here o tsaka here, yung distance ng field point mo to the origin is still equal to L. So hindi siya a changing variable but a constant variable. So we can take that outside. K lambda L. Then we have here DL. Tapos A squared plus L squared raised to 3/2. Okay? So that is your EX. So how about DL? So DL, how can we get DL? Now, as you can see here, yung DQ mo is actually para siyang arc, di ba? So kung ato ni siyang ikuan, kung ato na siyang kwaon, okay? So ato ning tan-awon, ang imuhang ato ni siyang i-zoom out, sumura siya ginaning nga part, okay? So i-zoom out na nato, mura siyang nagin-ana. Okay? So yung DQ mo, approximately i-zoom out nato siya. So mura siya gin-ani. Tapos this one is actually related to what they called as the arc length. So ito yung arc length mo, di ba? So that is actually equal to S is equal to the radius, which is A. Tapos the angle here, theta, that is the arc length. But your arc length is actually equal to ds kasi the space nga na occupy ni dq is actually just equal to ds or the arc length. So meaning we have to take the ds and your a is just constant, but your theta, so all throughout sa ring mo is nag-change siya, okay? Yung theta mo. So meaning that is ds d theta. So we can let your DL to be your arc length ds. So we have K lambda, tapos we have here L, then your DL is actually equal to ds, that is A d theta over A squared, okay, Control Z, A squared plus L squared raised to 3/2. Okay, so ito na. So okay, so let's start. So your d theta is actually equal to ano? Okay, so here yung a squared at L squared mo are all constant. So we can take all of them outside the integral expression. Okay, so K lambda L A, tapos meron tayong A squared plus L squared raised to 3/2, tapos the integral of d theta. So yung theta mo here is actually changing. So meaning that the theta here is changing. So kung moari ka diri mag-change na imuhang theta. So for the perfect circle, so for the rotate you ka in a one circle, that is actually equal to 2 pi. So meaning we have to integrate our d theta, the arc length na na-produce niya, from 0 to 2 pi or 360 degrees, di ba? So that is simply equal to 2 pi. Okay, so we have 2 pi K lambda LA, tapos we have here A squared plus L squared raised to 3/2. Now your lambda is actually the total line charge density. So we have here lambda as equal to the total charge, that is positive q, divided by the total length. So total length ng circle mo is actually the total circumference lang. So that is actually equal to 2 pi tsaka yung radius a. Okay? So substituting lambda to our EX expression, so that is equal to 2 pi k, that is q over 2 pi a. Then we have here L a divided by a squared plus L squared raised to 3 halves. So we have to cancel 2 pi a tsaka a. So what's left is kq L over a squared plus L squared raised to 3 halves. Okay? So that is your EX. So let's see. Okay, so this is your EX. But how about your EY? So your EY here is equal to 0 by symmetry. So what do you mean by that? Okay? So as you can see here that if we put another dq here, so magkuha tag dq na put here, so that is dq2. So then we have to put again the ano here. So meron siyang DE na ganito, 'di ba? So just like our problem number 1, meron siyang DEY tsaka meron siyang DEX. Tapos itong DE na to, so we can take this one as DE2 tapos DE1, so that is DQ1. Meron siyang contribution along X tapos contribution along Y. So since your origin is in the center gid siya, so we can actually put the expression as we can actually conclude na yung EY mo is actually mag-cancel out lang yung contribution niya. Okay? So anywhere on the circle. So if meron kang DQ1 here, so i-cancel out ng DQ2 here yung EY contribution mo. And then your EX naman is actually mag-add-add lang na siya. So anywhere, so add-add lang. So for every pa-up na EY, na-apoy pa-down nga EY. So i-cancel out siya. So that's why EY is equal to 0 by symmetry. Okay? So that's it. That's actually our... yeah. So question? Okay, so therefore our electric field expression is equal to kq L over a squared plus L squared raised to 3 halves I hat. So meaning yung total contribution ng ring of charge at point P is just actually pointing in the positive I hat direction. Okay? So let's proceed to a thin circular disc. So thin meaning wala siya kabag-on. Okay, so that is why we can actually in this problem we can let our ring to be approximately a surface. So meaning we will not dwell on the volume charge density. Okay, so we just have to stick with surface charge density. So our problem states that a disc of radius r has a total charge of positive q. So find the electric field at point P located on the x-axis at distance L from the center of the ring. So here, kung tanaw nato, so from our expression sa taas, we know that kabalo na ta sa electric field produced by a ring. Okay, so actually, ang atong thin circular disc, we can assume, or no, we will not assume, but your thin circular disc is in fact composed of many rings, di ba? So daghang kina siya ring diha. So ring, another ring here, another ring. Ang padulong sa iyahang total radius r. Okay? So what you're going to do is again get a very small ring of charge. As you can see here, may ring of charge tayo. Tapos yung field point P mo is located at distance L. from the origin or the center of the thin circular disc. So next is we just have to we know the expression na prior to this problem. So katong sa pinakauna natong expression, so recall that your E ring is actually equal to KQL over A squared plus L squared raised to 3 halves I hat. So let's see kung sakto ba. Yeah, so that is KQL A squared plus L 3 halves I hat. So next, yung contribution again. So what's left? What's left? Left. So here, earring. So the electric field produced by a one ring here is kani, diba? So we can let the electric field produced by the disc as equal to EX I hat plus EY J hat. Okay, so we have here EY J hat. Now here, okay, so EX is actually equal to K, the integral of dq over r squared, but we don't know the theta yet. So we can actually let the theta to be, so may ito yung expression na ganito. So base lang sa ring natin, so makita natin yung isang ring is, yung contribution niya is walang y component along, walang y component yung electric field natin. So kaya by symmetry, we can just put here nga yung EY mo is actually equal to 0. Okay, without even knowing the angle. Okay, kasi alam naman natin yung contribution ng ring natin na purely x component lang siya, or purely horizontal yung contribution niya. Okay? So here we just have to get the expression for the electric field produced by a disc. So a disc is composed of many rings. Okay? So here, okay na, so we will just let the so magkuha ta gamay nga charge diri, ring of charge. We will just let this one as your, say, ano yung ginalet niya, we just let this one as, say, so small letter A lang. Okay, okay, so wait lang. Okay, so I just have to analyze this one. So okay, so hindi to sin theta again, so this is actually cosine theta kung base sa inyuhang sa atong ring of charge, so that's cosine theta. So EX is actually equal to K. Tapos since we are talking about surface charge, so your dq can be equal to sigma dA. So we can take that one as sigma dA over r squared cosine of theta. But your sigma is actually constant, so we can take that outside. So K sigma, then we have here dA over r squared, tapos yung cosine theta mo is actually equal to the distance between the adjacent divided by the hypotenuse. So yung adjacent mo is yung L, and yung hypotenuse mo is si x squared plus L squared. So we can take the radius di here for this ring lang, specific ring, as x. So x is a changing variable kasi meron tayong mga rings dito. Okay? So we can let our r to be equal to the square root of x squared plus L squared. So ang x mo is the radius of that specific ring lang. Okay? Yung x mo. Lagi. So we have cosine theta, so that is L divided by x squared plus L squared square root. So simplifying, we have K sigma. So ano pala yung dA mo? So the dA is actually equal to the 2 pi x dx. So ito yung parang area ng specific circle mo, di ba? So that is just equal to sigma, but your dA is, we have 2 pi x, the circumference of this circle, and then the dx. So ito yung pang natin. So if we move a little for a small amount of the yung radius mo, parang x to x plus dx, parang ganun. So ito yung area ng ring of charge na ating pinili, okay, chosen. So your L here is actually a constant, so we can take that outside. Your dA is equal to this one, so we have 2 pi x dx. Then that is, so this one is actually x squared plus L squared raised to 3 halves. Now yung 2 pi mo is constant, so we can take that outside. So I will just put it below. So Ex, that is 2 pi k sigma L. But your x is actually not a constant variable. So that is the changing variable natin. So x squared plus L squared 3 halves. So here, ano yung limits of integration natin? So yung integration natin is yung radius, di ba? So yung radius is from 0 patungo sa total radius niya. So that is 0 to the ring of charge na may radius na capital letter R. So ito yung total radius ng disk natin. So that is 2 pi k sigma L. So integrated from 0 to R, we have x dx. Then we have here x squared plus L squared raised to 3 halves. So here we can integrate this one by integration by substitution. Okay, by substitution. So that is, we have here let u as x squared plus L squared. So du is actually equal to 2x dx. So yung x dx mo can be equal to du over 2. Okay, so we have here Ex. So 2 pi k sigma L. X dx is, we have du over 2. Tapos we have u raised to 3 halves. Again, yung 0 to r mo is not the limits in terms of du. So we just have to put this one as new lower limit and new upper limit para din ata malibog sa limits of integration. Okay? So we have here 2 pi k sigma L. So we can cancel 2 here, okay? Because naman siya 1/2. So that is, to integrate, so that is u 3 halves plus 1 over negative 3 halves plus 1 integrated from new lower limit tapos meron to new upper limit. So we have here pi k sigma L. Then we have here negative 1/2 here, so that becomes negative 2. So we have here negative 2 square root of, we just have to get the expression of u, that is x squared plus L squared integrated from 0 to r. Okay, so Ex is actually equal to negative 2 pi k sigma L. So we have to evaluate this expression. So we have here 1 over the square root of r squared plus L squared minus 1 over, so si x mo is 0, so that is 1 over L lang. Okay, so further simplifying, so we have here 2 pi k sigma L. Then we have here 1 over L minus 1 over, ako nang distribute ang negative sa sulod, okay? So square root of R squared plus L squared. Okay, so next. So again, so okay, since giing na naman tanga na ay total charge ang imuhang ring ay disk nga positive Q, so we can actually get the sigma. Okay, so we can get the surface charge density of this one. So either mag-stop mo here, or you can put sigma as, say, sigma, the total charge is Q, but the total area is actually equal to pi a square. Okay, so we have here 2 pi k, tapos yung sigma mo is Q over pi a square, tapos we have to distribute L sa sulod, so what's left is 1 minus L over the square root of R squared plus L squared. Okay, so here cancel pi, so what's left is equal to 2kq over a squared. Is it a squared? What is the total radius? R, so that is R, hindi siya a. So the total radius is R, so R. Then we have here 1 minus L over the square root of R squared plus L squared. Okay, so you can stop in this expression, or pwede put kaning expression. Anyway, they are just the same. So the electric field, total electric field, is actually equal to 2kq over R squared. Then we have here 1 minus L square root of R squared plus L squared I hat. Okay, so this is actually the electric field expression for a thin circular disc. Anyway, this is actually correct gihapon.